Hey everyone, tonight we're diving into one of history's most remarkable feats of human ingenuity, how the Vikings managed to sail across some of the world's most treacherous waters without GPS, compasses, or even accurate maps. So go ahead and get comfortable, maybe grab a warm drink, and if you enjoy this kind of content, consider subscribing. Now, dim the lights, settle in, and let's set sail into the North Atlantic together. The impossible ocean. Picture this. It's the year 870 CE and you're standing on a rocky Norwegian shore. The wind cuts through your wool cloak like a blade made of ice. In front of you stretches the North Atlantic, grey, churning, and absolutely massive. There are no lighthouses blinking in the distance, no buoys bobbing to mark safe channels, no coast guard standing by with rescue helicopters. Your boat, if you can even call it that, is made of overlapping oak planks held together with thousands of iron rivets and sealed with tar and animal hair. Your sail is woven from wool heavy when wet and prone to tearing in strong winds. And you're about to sail 600 miles across open ocean to Iceland, a place most of your neighbors aren't entirely sure exists. How? How did the Vikings do this? Not just once, as some desperate gamble, but repeatedly, successfully, year after year, establishing permanent trade routes from Scandinavia to North America, from the frozen Arctic to the sun-baked Mediterranean. How did they navigate waters that would terrify modern sailors even with all their electronic equipment? The answer isn't simple because the Vikings didn't have one trick. They had dozens. Navigation for them wasn't a single tool or technique. It was an entire cultural knowledge system passed down through generations, refined through trial and error, and occasionally, yes, through spectacular failure. For every ship that made it to Greenland, others vanished without a trace, swallowed by storms or lost in fog, their crews never seen again. But the Vikings kept sailing, kept learning, kept pushing further into the unknown, and what they developed out of necessity and ingenuity was one of the most sophisticated pre-modern navigation systems the world has ever seen. The Viking ship, a masterpiece of design. Before we talk about how Vikings navigated, we need to understand what they were navigating in. The Longship, that iconic vessel that appears in every Viking movie and video game, wasn't just a boat. It was a technological marvel, the result of centuries of incremental improvement and intimate knowledge of wood, water, and weather. Viking longships came in different sizes and styles depending on their purpose. The Snekkja was a smaller, faster warship, usually about 60 feet long, with room for maybe 25-30 oarsmen. The Drekar, or dragon ship, was larger and more intimidating, sometimes stretching over 100 feet with crews of 70 or more. But for long-distance ocean voyages, Vikings typically used the Nar, a wider, deeper, cargo vessel built for stability and storage rather than speed and intimidation. The Nar was the workhorse of Viking exploration. It could carry tons of cargo, livestock, timber, trade goods, supplies for establishing new settlements. It sat lower in the water than a longship, making it more stable in rough seas. Its hull was deeper, which meant it could handle the rolling swells of the open ocean without capsizing. And crucially, it had a large square sail that could catch wind efficiently, reducing the need for constant rowing on long voyages. But what made all Viking ships revolutionary was their construction method. The hull was clinker-built, meaning the planks overlapped like scales on a fish, each one riveted to the next. This created a hull that was both strong and flexible. When waves hit, the entire ship could twist and bend slightly, absorbing the impact rather than fighting it. Rigid ships snap. Viking ships danced. The keel, that long central timber running from bow to stern, was carved from a single oak tree, chosen for having a natural curve. This gave the ship its backbone. The The strakes, those overlapping planks, were split from logs along the grain, not sawn, which meant they retained the wood's natural strength. Every piece was carefully selected: oak for the hull because it was strong and water-resistant, pine for the mast because it was tall and flexible, birch for crossbeams because it handled stress well. And here's something most people don't realize. Viking ships had no decks, or not full ones anyway. The cargo area was mostly open, which seems insane when you're talking about ocean voyages. But this actually helped. Water that splashed over the sides could drain quickly through gaps in the floorboards. The ship wouldn't fill up and sink. Crews bailed constantly anyway, using wooden buckets and leather scoops, but the design helped them stay afloat. The sail itself was a feat of textile engineering. Made from wool, it had to be woven tightly enough to catch wind, but not so tightly that it couldn't breathe and shed water. Viking sails were often reinforced with a diamond pattern of leather strips or rope stitched across the surface to distribute stress. A fully equipped sail might require wool from 200 sheep and hundreds of hours of weaving by skilled women. It wasn't just a piece of cloth, it was the ship's engine. Steering was done with a side rudder, a large oar-like blade mounted on the starboard side near the stern. The word starboard actually comes from the Old Norse stjornbordi, meaning steering side. The helmsman controlled this with a tiller, making constant tiny adjustments to keep the ship on course. In rough seas, steering was exhausting work, requiring strength, timing, and an almost intuitive feel for how the ship wanted to move. These ships could sail in as little as 3 feet of water, which meant Vikings could beach them easily, pull them ashore for repairs, or navigate up rivers that other seafaring cultures couldn't access. They could sail or row depending on wind conditions, and in a pinch, they could be portaged, literally carried overland between waterways. This wasn't just transportation. This was adaptive technology, built by people who understood that survival at sea required flexibility, resilience, and respect for the elements, reading the water like a book. Let's start with something most landlubbers never consider. The sea itself talks. To you and me, waves are just chaos, water moving randomly, violently, without pattern or meaning. But to a Viking sailor who'd spent his entire life on the water, waves were a language as precise as any spoken tongue, and the ocean was having a very detailed conversation if you knew how to listen. Vikings studied wave patterns obsessively. They knew that waves behave differently near land versus open ocean. In deep water, swells are long and rolling, moving in consistent sets shaped by distant storms. But when those swells approached an island or coastline, even one you couldn't see yet, they bounced back, creating interference patterns. Waves would suddenly become choppier, more confused, coming from multiple directions at once. A skilled navigator could feel these changes in the ship's movement, sense the rhythm shift beneath his feet, and know that land was near, sometimes 30 or 40 miles before it came into view over the horizon. This wasn't guesswork or mysticism. It was pattern recognition developed over thousands of hours at sea. They also watched the color of the water obsessively. Deep ocean water is a different blue-black than coastal waters, which often carried sediment and appeared more green or brown. Changes in color meant changes in depth, which meant you were approaching a continental shelf, an underwater bank, or land itself. Seaweed floating in clumps, you're near coastal shelves where vegetation grows. Long strands of kelp, you're very close to shore, possibly dangerously so if you can't see rocks yet. Cloudy, silty water was a sign of a river mouth nearby, fresh water mixing with salt water and carrying soil from inland. Vikings could sometimes identify which river based on the color and composition of the sediment. The water near the mouth of the Rhine looked different from the water near the Thames, and experienced sailors knew the difference. Even the smell mattered. Vikings could reportedly smell land before seeing it. The scent of pine forests carrying on offshore winds, the distinctive odour of peat bogs in Ireland and Scotland, or even specific types of soil and vegetation. Greenland, despite its misleading name, had a particular smell when the wind blew from land, a mixture of tundra grass, moss and ice. Iceland smelled of volcanic sulphur and birch scrub. Norway smelled of pine and spruce. Their sense of the ocean wasn't just visual, it was multisensory, almost primal. They tasted the water too, not drinking it obviously, but checking salinity. Near river mouths or after heavy rain, the sea became less salty. This told them they were near significant freshwater outflows, which meant land and usually harbours. Water temperature was another clue. Vikings would cup seawater in their hands throughout the day, noting changes. Warmer water might indicate they'd crossed into a current like the Gulf Stream. Colder water suggested Arctic currents from the north. These thermal boundaries often corresponded with changes in weather patterns and sea life, providing additional navigation clues. They watched foam and debris floating on the surface. The way foam gathered or dispersed indicated wind patterns and current directions. Driftwood was particularly valuable, not just because it could be salvaged for fuel or repairs, but because specific types of wood floating in the water indicated proximity to certain coastlines. A piece of spruce driftwood in the mid-Atlantic suggested you were in the track between Scandinavia and Iceland. Tropical hardwood meant you drifted south toward warmer latitudes. Ice was both hazard and signpost. Pack ice from Greenland drifted south in predictable patterns. Icebergs carving from glaciers followed certain routes. Vikings learned to read ice the way desert nomads read sand dunes, understanding where it came from, where it was going, and what it told you about your position. Spotting ice too early in the season meant you'd sailed too far north. Seeing no ice when you expected it meant you'd drifted south or that weather patterns had shifted. Even the feel of the wind on your face carried information. Wind from different directions had different qualities: temperature, humidity, steadiness. A steady wind from the west in the North Atlantic was the prevailing pattern, reliable for days. A sudden shift to northerly winds often brought storms. Gusty, variable winds suggested you were in the wind shadow of an island or near a coast where land affected airflow. All of this. Knowledge. The waves, colours, smells, temperatures, ice, wind was processed simultaneously by experienced navigators. They weren't thinking consciously about each element. They'd internalized it to the point where it was intuitive, automatic. They felt wrongness the way you might feel someone staring at you or sense that you've forgotten something important. This is what made a master navigator invaluable. Anyone could learn to row or handle a sail. But reading the water? That took years, decades even, of constant observation and survival pressure. And when your navigator died or was lost at sea, replacing that knowledge was nearly impossible. It's one reason why navigators commanded such respect in Viking society and why their deaths in battle or storms were mourned as community tragedies. The sun, compass, and solar navigation. Now, the Vikings didn't have magnetic compasses. Those wouldn't arrive in Europe for another few centuries, probably imported from China via Arab traders. But they did have the sun, and they knew how to use it with frightening precision. The sun, after all, is the most reliable celestial object we have. It rises in the east, sets in the west, and traces a predictable arc across the sky. For a seafaring people whose survival depended on knowing which direction they were heading, the sun was everything. During long summer days in the Arctic, the sun barely sets. In northern Norway, northern Iceland, and Greenland during June and July, you experience the midnight sun, The sun literally visible 24 hours a day, just dipping toward the horizon before climbing again. It traces a long, lazy arc across the sky, and if you know the time of year and can track the sun's position relative to your ship, you can determine direction fairly accurately. Vikings likely used sun compasses, simple but effective wooden discs with a central gnomon, basically a vertical stick or peg that cast a shadow. The concept is beautifully simple. Place your disc level on a surface, let the gnomon cast a shadow and mark where that shadow falls. Do this at regular intervals throughout the day, and you create a curve of shadow points. This curve tells you the sun's path relative to your position. In 1948, archaeologists discovered what might be a Viking sun compass in Greenland, though its authenticity and purpose are still debated. It was a wooden disc fragment with carefully carved notches around the edge and a hole in the center where a gnomon would have stood. The notches appeared to mark regular intervals, possibly hours or shadow positions. Here's how it would work. Before your voyage, you'd create reference marks for the sun's shadow path during a specific time of year at a known latitude. Let's say you're leaving from Bergen, Norway in early June. You'd mark your disk throughout a single day, noting where the shadow fell at sunrise, mid-morning, noon, afternoon, and sunset. This creates your baseline. At sea, you'd set up your compass and compare the current shadow to your reference marks. If the shadow matched your baseline, you were at roughly the same latitude as Bergen. If it was different, you'd sail north or south. To maintain a constant latitude, say, to sail from Norway to Iceland at the same parallel, you'd adjust your course to keep the shadow pattern consistent with your reference marks. But here's where it gets tricky. What about cloudy days? What about fog, which is constant in the North Atlantic? What about rain, snow, or the thick mists that could blanket the ocean for days? The sun compass was useless if you couldn't see the sun, and in the North Atlantic, clear days are the exception, not the rule. This is where Vikings needed backup methods. They used time estimation, basically very good internal clocks developed through routine and repetition. If you last saw the sun at what you judged to be mid-morning, and you'd been sailing for roughly 3 more hours based on the rhythm of the oars, changes in the crew, meal times, and pure gut feeling, you could estimate the time and therefore roughly where the sun should be even if you couldn't see it. They also used the principle of swimming the ship, maintaining a dead reckoning based on speed, time, and last known direction. This required constant mental calculation. If we were sailing west at roughly 5 knots and we've been going for 6 hours, we've covered about 30 nautical miles in that direction. Adjust for current if known, adjust for drift, keep a running mental tally. It's exhausting and error-prone, but better than nothing. The angle of the sun at noon, when it reached its highest point, was particularly important. This solar noon altitude told you your latitude directly. If you measured the sun's angle at its highest point and compared it to what you knew that angle should be at different latitudes, you could calculate how far north or south you'd traveled. Vikings didn't have sextants or precise angle measuring tools, but they had experience and some crude measuring methods using handspans, finger widths held at arm's length, or marked sticks to estimate angles. Some historians believe Vikings may have used simple sundials not for telling time, but for checking the sun's bearing. If you know the sun should be at a certain position at noon, and you have a crude dial that shows where the shadow falls, you can verify you're on course. Solar navigation also meant understanding seasonal changes. The sun's path shifts throughout the year. In summer, it rises and sets further north. In winter, further south. The length of the day changes dramatically at northern latitudes. A Viking navigator had to internalize these patterns, knowing instinctively that in early May, at 60 degrees north latitude, sunrise would be at roughly this angle, sunset at that angle, and noon altitude would be approximately this high. This knowledge wasn't written down in tables or charts, it was memorized, taught through apprenticeship, refined through experience. Young boys training to be navigators would spend years watching the sun, marking its positions, learning the seasonal shifts. They'd practice on land first, setting up sun compasses in their home fjords, checking and rechecking their readings against known landmarks. Only after years of training would they be trusted to navigate open ocean crossings. Because errors compounded. A mistake of just a few degrees maintained over several days could put you hundreds of miles off course. In the empty Atlantic, that could mean missing Iceland entirely, sailing past it into empty ocean till your supplies ran out and your crew died of thirst. Stakes were absolute. The legendary sunstone, myth or marvel? Saga texts occasionally mention a mysterious solarstein or sunstone that could locate the sun even through clouds or fog. For years, historians dismissed this as pure mythology, another example of saga writers embellishing reality with magical elements. Viking tales are filled with enchanted swords, dragons, magical rings, and prophecies. Why should a mystical crystal that reveals the sun be any different? Then someone did the science. And things got interesting. Certain crystals, like Icelandic spar, a form of calcite, have unique optical properties called birefringence. When light passes through these crystals, it splits into two rays that travel at different speeds and vibrations. This creates a double image when you look through the crystal. But here's where it gets really interesting. These crystals can detect the polarization pattern of sunlight. Even when the sun is completely hidden by clouds, sunlight in the sky remains polarized in predictable patterns based on the sun's position. It's like the sun leaves a fingerprint on the sky even when you can't see it directly. The polarization forms a distinctive pattern centered on the sun's location. When you hold a calcite crystal up to the sky and rotate it, the double image changes appearance. The two refracted images become lighter or darker, more or less distinct, as the crystal's alignment changes relative to the polarization pattern. When you find the orientation where the two images are equally bright, you've aligned the crystal with the polarization direction. Do this from multiple points in the sky, and you can triangulate the sun's position. Did Vikings actually use these? We have no direct archaeological evidence. Crystals don't preserve well, they dissolve in water over centuries. And even if one was on a shipwreck, we might not recognize it as a navigation tool. But we know these stones existed in Scandinavia. Iceland is literally made of volcanic rock, and calcite formations are common there. Feldspar and cordierite, other crystals with similar properties, are found throughout Norway and Sweden. More compelling is a discovery from 2013. Archaeologists excavating a 16th century English warship, the Elizabeth, found a piece of Icelandic spar among the navigation equipment. This was centuries after the Viking Age, but it suggests that European navigators knew about and used these crystals for navigation long before modern science understood why they worked. A 2011 study tested this technique on a Viking ship replica sailing near Greenland. Researchers deliberately created conditions where the sun was obscured by fog and clouds. Navigators, using only calcite crystals and the polarization method, were able to determine the sun's position to within a few degrees of accuracy, more than precise enough for practical navigation. A follow-up study in 2013 modeled an entire transatlantic crossing using only sunstone navigation. The simulation showed that even under heavily overcast conditions, navigators could successfully sail from Norway to Greenland with acceptable accuracy, arriving within 50–100 miles of their target. Given that Greenland is a massive landmass over 1,600 miles long, that margin of error was perfectly acceptable. But let's be honest, using a sunstone required incredible skill. You weren't just holding up a crystal and getting a GPS readout. You had to understand crystal optics intuitively, recognize subtle changes in the refracted images, take multiple readings from different parts of the sky to verify accuracy, and then translate that information into a heading in rough seas on a pitching, rolling deck while cold and exhausted. Not easy. Some researchers theorize that sunstones were used in combination with other methods as a cross-check. You'd use your sun compass when possible, maintain dead reckoning based on speed and time, watch for land indicators like birds and seaweed, and then periodically verify your bearing using a sunstone when conditions were too overcast for direct solar observation. The saga descriptions of sunstones are frustratingly vague. They're mentioned in passing almost casually, as if the audience already knew what they were. King Olaf looked at the sky, which was completely overcast, and used his sunstone to locate the sun's position. That's it. No detailed description of technique, no explanation of how it worked. This actually lends credibility to the idea that these were real tools. If the saga writers were inventing a magical plot device, they'd probably make it more dramatic. What's certain is that Vikings navigated successfully in conditions that would ground modern sailors without instruments. They crossed thousands of miles of open ocean repeatedly, establishing permanent settlements in Iceland, Greenland, and even North America. They did this during periods of frequent fog, during seasons with minimal daylight, through storms and snow. Whether they used calcite crystals, pure skill and luck, or some combination we don't fully understand, they succeeded. The settlements exist. The archaeological evidence is undeniable. So maybe the sunstone wasn't magic. But from a modern perspective, what the Vikings achieved without any of our technology feels pretty magical anyway. Birds as living compasses. Vikings also brought ravens on long voyages, not for company, not as pets, but as living GPS units. This practice is mentioned in multiple sagas, most famously in the story of Hrafna Flóki, or Raven Flóki, one of the first Norse explorers to attempt reaching Iceland. His nickname literally means Raven Flóki because of his navigation method, and it makes perfect sense when you think about animal behavior. Here's how it worked. When you'd been at sea for days and weren't sure if land was nearby, you'd release a raven from a cage or basket kept on the ship. Ravens, being land birds and highly intelligent, won't willingly stay over open ocean if they have any alternative. They need trees, cliffs, or ground to rest on. They feed on carrion, insects, and small animals, none of which exist in the middle of the ocean. If the raven flew up, circled the ship a few times to get its bearings, then took off in a particular direction and didn't return, you followed it. Land was that way, probably within 50–100 miles. The raven could see further from altitude than a man on a ship's deck. Birds have better eyesight than humans anyway, and from several hundred feet up, they could spot land beyond the horizon that was invisible to sailors. If the raven circled, gained altitude, looked around, and then came back to land on the ship, you knew you were still in the middle of nowhere. The raven had looked in all directions and seen nothing but water. Time to keep sailing on your current bearing and try again tomorrow. According to the saga, Flóki brought 3 ravens on his voyage to Iceland. He released the first one shortly after leaving the Faroe Islands. It immediately flew back east toward the Faroes. They hadn't gone far enough yet. Later, he released the second raven. This one circled and returned to the ship, still surrounded by empty ocean. Finally, after more days of sailing west, he released the third raven. This one flew straight ahead to the northwest and didn't return. Floki followed and eventually spotted the coast of Iceland. Was this real or embellished? Probably a bit of both. The story might exaggerate the precision of the method, but the underlying technique is completely plausible. Other cultures used similar methods. Polynesian navigators released birds to find islands. Arab sailors in the Indian Ocean used frigate birds. Chinese explorers did this too. It's a clever exploitation of animal behavior that requires no technology beyond a cage. Other birds helped in different ways. Certain seabirds like puffins, gannets, and guillemots only feed near shore. They need cliffs or islands for nesting, and they don't venture more than maybe 50-70 miles from land, even when fishing. If you spotted them in large numbers, especially in the evening when they'd be returning to their nests, you were within a day's sail of coastline. Puffins in particular were reliable indicators. These distinctive black and white birds with colourful beaks nest in colonies on coastal cliffs from Norway to Iceland. If you saw puffins in the late afternoon flying steadily in one direction, you followed them. They were going home, and home meant land. Gannets and their characteristic plunge diving behavior signaled rich fishing grounds, which were almost always near coastlines or underwater banks. Vikings didn't just want to find any land, they wanted to find areas with good fishing and resources. Gannets diving repeatedly into the water to catch fish were like big, white arrows pointing toward valuable territory. Even driftwood behavior was meaningful. Certain types of wood floated differently depending on how waterlogged they were. Fresh driftwood recently washed into the sea would float high and move with the wind and surface currents. Old driftwood soaked for months would sit lower and move with deeper currents. By watching driftwood and comparing its direction of drift to wind direction, Vikings could estimate current flow, which helped them understand where they were in the ocean's circulation patterns. Arctic terns, those incredible birds that migrate from Arctic to Antarctic and back every year. The longest migration of any animal, were also helpful. Seeing terns meant you were in their migration corridor, which followed specific routes and latitudes. Time of year mattered too. Terns in the North Atlantic in summer meant one thing. Seeing them heading south meant autumn was coming, and you'd better finish your business and get back home before winter storms hit. Whales were another indicator. Different whale species frequented different waters. Minke whales preferred coastal areas. Blue whales favored deeper water. Orcas, those apex predators, Vikings both feared and respected, often hunted near seal colonies and fish runs, which meant shorelines and underwater geography that concentrated prey. Spotting orcas didn't tell you exactly where you were, but it told you that interesting things were happening beneath you. Shallow waters, reefs, upwelling currents, bringing nutrients and fish. Seals hauling out on ice floes indicated proximity to pack ice and Arctic waters. If you were aiming for Greenland, seals were a good sign. If you were trying to reach Iceland and suddenly encountered seal herds, you'd sailed too far north and needed to adjust course south. Even insects played a role. Land-based insects blown out to sea would appear on ships when close to shore. Finding a moth, beetle, or dragonfly on your sail in the middle of the ocean meant land was upwind, probably within a few dozen miles. Vikings would even catch these insects and watch which direction they tried to fly, invariably toward the land they'd come from. This ecological awareness, this ability to read animal behavior and treat the natural world as a navigation system, is something modern people have almost completely lost. We see birds as just birds, whales as just whales. Vikings saw them as information, as living signposts in an otherwise featureless ocean. It wasn't romantic nature worship. It was survival, star navigation, and the celestial sphere. At night, when the sun disappeared below the horizon and the ocean turned black and silver under the moon, Vikings turned their eyes upward to the greatest navigation tool humanity has ever had, the stars. The night sky, unlike the chaotic ocean or unpredictable weather, was reliable, eternal, and if you knew how to read it, extraordinarily informative. The North Star, Polaris, was their anchor, their fixed point in a rotating cosmos. While every other star and constellation wheeled across the sky throughout the night and throughout the year, Polaris stayed put, hovering almost directly above the North Pole. Its position was so reliable that Vikings called it Ledarstjarna, the leading star or guide star. Here's the beautiful thing about Polaris: its altitude above the horizon directly corresponds to your latitude. If you're standing at the North Pole, Polaris is directly overhead at 90 degrees. At the equator, it's on the horizon at 0 degrees. Everywhere in between, the angle matches your latitude. Stand in southern Norway at roughly 60 degrees north, and Polaris sits about 60 degrees above the northern horizon. This means that if you knew how high Polaris sat above the horizon at your home port, you could maintain that latitude indefinitely while sailing. This technique, called latitude sailing, was simple but devastatingly effective. Want to get from Norway to Iceland? Figure out what latitude the southern coast of Iceland sits at, about 63-64 degrees north. Sail west while keeping Polaris at that exact angle above the horizon. Just sail west, constantly checking the North Star's altitude. Eventually, guaranteed, you'd hit Iceland. You might miss your specific target fjord or settlement, but you wouldn't miss a landmass that's nearly 500 miles across. The Vikings didn't have sextants or precise angle measuring instruments, but they had methods. The simplest was using your hand at arm's length. A closed fist is about 10 degrees. An extended hand, fingers spread, is about 20 degrees from thumb tip to pinky tip. These aren't precise, but they're consistent for an individual. A navigator would calibrate his own hand against known landmarks and Polaris altitude at home, then use the same method at sea. Some historians believe Vikings may have used notched sticks or boards as crude angle measuring devices. You'd sight along the board with one end held at eye level, aligned with the horizon, and note where Polaris appeared relative to notches carved into the wood. Not accurate to the degree, but good enough to maintain latitude within maybe 20-30 miles, which was sufficient. The Big Dipper, or as the Norse knew it, Karlsvogn, Charles's wagon, or Odin's wagon, was another crucial constellation. It's easily recognizable, 7 bright stars forming a distinctive scoop or wagon shape. More importantly, it circles Polaris, rotating counterclockwise throughout the night and throughout the year. The Big Dipper acted as a celestial clock. Vikings didn't have pocket watches or ship's chronometers, but they could estimate the time of night by noting the Dipper's position relative to Polaris. Imagine Polaris as the center of a clock face and the Big Dipper's pointer stars, the 2 stars forming the front edge of the Dipper's scoop, as the hour hand. The position of these stars told you roughly what time it was. Knowing the time was crucial for dead reckoning. If you knew you'd been sailing for approximately 8 hours based on the stars' positions and you estimated your speed at 5 knots, you'd covered about 40 nautical miles. Combined with your heading, this gave you an estimated position. Other constellations helped too. Cassiopeia, that distinctive W-shaped constellation, also circles Polaris opposite the Big Dipper. When the Dipper was low on the northern horizon, Cassiopeia was high and vice versa. Having both gave navigators a full circle reference around the North Star. In the southern hemisphere or tropics, where Polaris isn't visible above the horizon, Vikings had to use different techniques. They relied more on the sun's rising and setting points, which shift throughout the year based on seasons. The sun doesn't rise due east and set due west except on the equinoxes, around March 20th and September 27th. In summer, it rises and sets much further north. in winter much further south. An experienced navigator had these patterns memorized. In early June at 60 degrees north, sunrise is about 45 degrees north of east and sunset about 45 degrees north of west. The sun barely sets at all, skimming the northern horizon briefly before rising again. In December, sunrise is about 45 degrees south of east, and the sun barely climbs above the southern horizon at midday. This knowledge allowed rough directional navigation even without stars. If you saw the sunrise and knew roughly what date it was and what latitude you were at, you could estimate east's actual direction and adjust your bearing accordingly. The moon helped too, though its phases and position were more complex and harder to use for precise navigation. But a full moon rising in the east or setting in the west provided additional directional confirmation, and moonlight on the water, while not as bright as sunlight, still allowed some visual navigation at night. You could see wave patterns, spot icebergs, and avoid obstacles. Planets were noticed and tracked, though Vikings probably didn't use them for navigation as much as later European navigators would. Venus, as the evening or morning star, was bright and distinctive. Mars with its reddish color, Jupiter as the brightest object in the night sky after the moon, and Saturn, all were observed and given names in Norse mythology. But their movements were complex, and they weren't as useful as the fixed stars for practical navigation. The Milky Way, that cloudy band of billions of stars stretching across the night sky, was called Vetrarbraut, or Winter Street, by the Norse. It roughly aligned with the cardinal directions at certain times, providing another crude reference. And on truly clear nights in the Arctic, far from any light pollution, the Milky Way was so bright you could almost read by it. The sheer number of visible stars, thousands upon thousands, must have been both overwhelming and comforting to sailors far from home. Aurora Borealis, the northern lights, were mysterious and somewhat frightening to Vikings. They called them different names: Nordurljos, northern lights, or believed they were reflections from the shields of Valkyries riding across the sky. While beautiful and memorable, auroras weren't useful for navigation and sometimes made it harder to see stars clearly. Cloud cover was the eternal enemy of celestial navigation. On overcast nights, which were common in the North Atlantic, Vikings had to rely entirely on dead reckoning, feel, and luck. This is where experience mattered most. A navigator who'd made a crossing dozens of times developed an almost supernatural sense of where he was, based not on any single indicator, but on the sum total of 1,000 small observations and instincts built over years. The stars couldn't tell you your longitude, your east-west position. That wouldn't be solvable until the invention of accurate chronometers in the 18th century. But for latitude, for maintaining a consistent northern or southern position, the stars were perfect. And combined with dead reckoning for east-west progress, it was enough. Mental maps and the power of memory. Here's something modern people, accustomed to GPS and printed charts, struggle to truly grasp. Vikings didn't write down their routes. There were no nautical charts in the Viking Age, no maps showing here be Iceland, with helpful distance scales and compass roses. No leather-bound logbooks with neat entries about daily positions and weather conditions. Navigation knowledge lived entirely in the minds of experienced sailors and was passed down orally, father to son, mentor to apprentice, through years of patient teaching and dangerous practice. This wasn't because Vikings were illiterate, some certainly were, but runes existed and were used for various purposes. It was because practical navigation knowledge simply couldn't be effectively captured in writing with their available technology. How do you write down what the water looks like when you're 12 hours west of the Faroe Islands? How do you describe the particular feel of the wind shift that tells you a storm is coming? How do you catalogue the thousands of specific observations that together create an instinct for where you are. They memorized coastlines in extraordinary, almost unbelievable detail. The shape of cliffs, the color of beaches, the angle at which fjords cut into the land, the height and profile of mountains visible from sea. Specific rocks, islands, headlands, and underwater features were catalogued mentally. Every landmark that might be visible from a ship's deck was noted, named, and memorized. The sagas occasionally give us glimpses of how detailed this knowledge was. Sailing directions passed down in oral tradition might sound something like this. Sail west from Bergen, keeping the mountains to your stern until they disappear below the horizon. Continue for 2 days and nights with the wind from the northeast. On the third morning, you'll see a pair of birds-shaped rocks rising from the sea. Pass these on your starboard side. By evening, watch for a seal colony on a black rock formation that looks like a sleeping bear. When you see this, turn northwest. Half a day later, you'll spot the southern coast of the Shetlands, recognizable by white cliffs with distinctive red layers. This wasn't vague, it was hyper-specific. And it had to be, because your life depended on it. Forgetting a landmark could mean sailing into a hidden reef, missing a safe harbor during a storm, or passing your destination entirely and sailing on into empty ocean until your water ran out and your crew died. Some historians believe Vikings used what cognitive scientists now call memory palaces, or the method of loci, mental architectures where information is stored spatially. Essentially, you create an imaginary building or landscape in your mind, and you place pieces of information at specific locations within it. To recall the information later, you mentally walk through your palace and pick up the items you stored there. For a Viking navigator, the memory palace might be the entire North Atlantic. Each headland, each island, each notable feature would have a specific place in their mental geography. They'd visualize the journey as a path through this internal landscape, knowing that after Landmark A came Landmark B, then a day of open water, then Landmark C would appear. The route wasn't just a list of points, it was a story, a narrative journey with specific scenes that unfolded in order. This knowledge was precious and closely guarded. A master navigator was valuable not just for his skill, but for the irreplaceable information he carried in his head. When a famous navigator died, communities mourned not just the person, but the loss of knowledge that might have died with him. This is why navigation skill was often kept within families, passed from father to son or uncle to nephew, creating hereditary lines of expert sailors. Young boys training to be navigators would start their education early, sometimes as young as 6 or 7. They'd make short coastal voyages first, learning to recognize their home fjords and nearby islands from the water. Perspectives look different from sea than from land. They'd memorize the positions of rocks and shallows, learn to judge distances, practice estimating the ship's speed. As they got older, they'd venture further, multi-day voyages to neighboring regions, always accompanied by experienced navigators. They'd be tested constantly. What's that headland called? How far to the next harbor? What direction is the wind coming from? Where will we be by sunset if we maintain this heading and speed? Wrong answers weren't just failures on a test, they were potentially deadly mistakes. The training process took years, often a decade or more, before a young man was trusted to navigate independently on major voyages. Some never made the grade. Navigation required a specific type of intelligence: spatial reasoning, memory, attention to detail, the ability to make quick mental calculations, and perhaps most importantly, an almost instinctive feel for the sea that some people simply never developed. Interestingly, this oral tradition and memory-based navigation actually had some advantages over written charts. Mental maps could be updated instantly based on new experience. If a storm revealed a previously unknown shoal or a coastline had changed due to erosion, The navigator simply updated his mental model. No charts to redraw, no outdated information to cause confusion. Memory-based navigation was also flexible and adaptive. A navigator didn't just remember, at point X, turn north. He remembered, why? Turn north here because there's a reef extending west from that headland, and the current sweeps you toward it if you don't adjust course. This contextual understanding meant that if conditions were different than expected, maybe the tide was wrong or the wind was from an unusual direction, the navigator could adapt, understanding the underlying reasons behind the route rather than just following memorized steps. The downside, of course, was that this knowledge was fragile. It lived in human brains, vulnerable to death, injury, or simply forgetting. A navigator who suffered a head injury and lost memory could lose years of accumulated knowledge. Disease, battle, drowning, all could wipe out irreplaceable information in an instant. This is probably one reason Vikings placed such emphasis on honor, reputation, and the telling of stories. Your deeds, your knowledge, your contributions to your community. These lived on after death only if people remembered and spoke of you. A great navigator who died might be commemorated in poems and sagas, and his most famous routes and discoveries would be named after him, keeping his memory and his knowledge alive. Soundings and depth, reading the seabed. When approaching land, especially in fog or darkness, Vikings used lead lines, weighted ropes dropped overboard to measure depth. This technique, called taking soundings, was one of the oldest forms of navigation, predating Vikings by millennia. But Vikings refined it and used it with particular skill, turning a simple depth measurement into a sophisticated positioning system. The basic tool was straightforward: a rope marked at regular intervals. Fathoms, each about 6 feet, were common, with a heavy lead weight tied to the end. The weight at the bottom wasn't just heavy, it was hollowed out and filled with sticky tallow or animal fat. When it hit the seabed, sediment would stick to the tallow, pull it up, and an experienced sailor could identify where they were based on the sample. Grey sand with shell fragments. You're off the coast of Denmark, approaching shallow Baltic waters, black volcanic sand, probably near Iceland, mud with a particular colour or smell. That's the characteristic sediment from a specific fjord or river mouth. Gravel, mixed with small stones. You're on an underwater bank or approaching a rocky coastline. Fine silt, river delta ahead. The level of detail that could be extracted from these sediment samples was remarkable. Vikings spent their entire lives handling different types of soil, sand, and stone. They knew the geology of their home regions intimately. This tactile, sensory knowledge translated directly to the seafloor. A handful of sediment wasn't just dirt, it was information, a fingerprint of location. Depth itself provided crucial navigation data. Vikings knew the underwater topography of their regular routes, as well as they knew surface landmarks. The approaches to major harbors had distinctive depth profiles. You'd hit a particular depth at a certain distance from shore, then as you continued, the bottom would gradually rise or suddenly shallow as you crossed a bank. Following these depth contours could guide you into harbor even in complete fog. In some cases, underwater canyons or channels created distinctive patterns. The approaches to certain Norwegian fjords, for instance, had deep channels carved by ancient glaciers, surrounded by shallower banks. By taking soundings every few minutes and noting how the depth changed, a navigator could determine whether he was in the channel, and therefore heading straight into the fjord entrance, or off to one side where he'd eventually run aground. This technique required constant vigilance and manual labor. Taking soundings wasn't a quick process. You'd heave the lead line forward while the ship was moving, let it sink to the bottom, which could take considerable time in deep water. Feel the lead hit bottom through the rope, pull it back up, hand over hand, while counting the depth markers, examine the sediment sample, then do it all over again a few minutes later. In dangerous waters approaching unfamiliar coasts or during poor visibility, a dedicated crew member might take soundings continuously for hours. It was exhausting, cold work, your hands constantly wet, arms aching from hauling up the heavy lead weight dozens of times. But it was the difference between safe navigation and shipwreck. Some Viking ships even had distinctive positions designated for the sounding man, usually near the bow where he could heave the lead line forward and have it reach bottom before the ship passed over the spot. In a well-coordinated crew, the sounding man would call out the depth constantly, and the helmsman would adjust course based on that information, keeping the ship in safe water. Depth information was also memorized and passed down as part of the oral navigation tradition. Sailing directions might include, when you're 2 days west from the Faroes and the depth suddenly increases from 50 fathoms to beyond your line's reach, you've crossed the edge of the continental shelf into deep ocean. Continue west-northwest for another day. Or, approaching the southern tip of Iceland, watch for depth to decrease to 30 fathoms, then suddenly drop to 60. That's the underwater ridge extending south, pass east of it to avoid the current. This three-dimensional awareness of underwater geography is something most modern sailors lack. We rely on depth sounders, electronic devices that ping sonar and display depth on a screen. We don't physically feel the bottom, don't smell or touch the sediment, don't develop that intimate knowledge of what lies beneath. Vikings had no choice but to develop it, and in doing so, they turned the invisible seafloor into another page of their mental atlas. There's something profound about this. Vikings understood that the ocean wasn't just a flat surface. It was a complex, three-dimensional space with deep trenches, rising banks, hidden reefs, and mountain ranges entirely underwater. Modern oceanography, with all its sophisticated technology, is only just beginning to map the seafloor in detail. Vikings did it one rope length at a time, through patient repetition and accumulated experience. Weather prediction. Reading the sky and sea. Vikings couldn't check weather apps or receive storm warnings from meteorologists. They couldn't access satellite images showing approaching fronts or computer models predicting wind patterns, but they became masters at reading the natural world, observing subtle signs that telegraphed coming weather changes hours or even days in advance. In an environment where storms could appear suddenly and destroy ships in minutes, this skill was literally survival. Clouds were the first textbook. Vikings developed a sophisticated understanding of cloud types and their meanings, though they didn't use modern meteorological terminology. They had their own names and descriptions passed down through generations of observation. High, thin, wispy clouds, what we call cirrus, often appeared 24-48 hours before a storm system. Vikings called them weather wisps or storm daughters. If you saw these clouds thickening and lowering over the course of a day, a major weather change was coming. Time to seek harbor if possible, or at least prepare the ship and crew for rough conditions. Towering vertical clouds building during the afternoon, cumulonimbus in modern terms, meant possible squalls and sudden wind shifts. If these clouds turned dark at the base and took on a greenish tint, severe weather, including possible waterspouts or extreme winds, was likely. Smart captains would change course to avoid sailing under these formations if possible. A solid grey, overcast with low racing clouds, stratus and stratocumulus, usually brought sustained rain or snow, but winds were often manageable. This was unpleasant, but not necessarily dangerous. The ship and crew would be wet and cold, but the vessel could continue making progress. The color of clouds at sunrise and sunset was particularly meaningful. The old sailors saying, "Red sky at night, sailors delight. Red sky in morning, sailors take warning," was as true for Vikings as for later mariners. A red or orange sky at sunset, caused by sunlight filtering through dry air from the west, the direction weather typically comes from in the North Atlantic, meant high pressure, and clear weather were approaching. Red sky at sunrise meant that clear, dry air had already passed east of you, and the sun was now illuminating moisture-laden clouds approaching from the west. Rain and wind were coming. Wind direction and steadiness provided critical information. In the North Atlantic, prevailing winds generally blow from the west or southwest during much of the year. A steady, moderate wind from this direction was ideal for Viking sailors heading west toward Iceland or Greenland. They could maintain a good sailing angle and make steady progress. But wind shifts were warnings. A sudden change from west to north often meant a cold front passing through, bringing possible storms. Wind swinging around to the southeast and increasing in strength indicated a low-pressure system approaching, bringing extended periods of rain, high winds, and rough seas. This was the pattern that created the legendary Atlantic storms that could sink ships. Wind backing, shifting counterclockwise, say from west to southeast, generally indicated worsening weather. Wind veering, shifting clockwise, often meant improving conditions. Vikings observed these patterns constantly and adjusted their plans accordingly. The appearance of a halo around the sun or moon caused by ice crystals in high-altitude clouds was a reliable sign that precipitation was coming within 24-48 hours. The crystals that created the halo were part of the leading edge of a storm system. Modern meteorology confirms this. A 22-degree halo around the sun or moon forecasts approaching frontal systems with about 70-80% accuracy. The behavior of the sea itself told stories. Long, smooth swells rolling from a consistent direction indicated distant weather. These swells could travel thousands of miles from their origin point. But when swells started coming from multiple directions, creating a choppy, confused sea, it meant weather systems were colliding and conditions would deteriorate. Waves with white, foamy crests appearing even in moderate wind meant the wind was intensifying and conditions were becoming dangerous. If the tops of waves started blowing off in streaks of spray, you were in serious wind, possibly gale force or higher. The sound of the wind changed as it intensified. In light winds, you heard the sail flapping and ropes creaking. In moderate winds, a steady humming or whistling through the rigging. In strong winds, a deeper roar. And in storm force winds, a scream that made communication nearly impossible and frightened even experienced sailors. Air temperature and humidity shifts were noticeable. A sudden drop in temperature often preceded cold fronts and storms. A warm, humid feeling with hazy visibility meant warm air was moving in, possibly bringing fog. Vikings sailing from cold northern waters toward warmer southern regions or vice versa would feel these transitions distinctly. Animal behavior provided additional clues. Seabirds flying low and close to the water rather than soaring high indicated low pressure and possible storms. Birds heading rapidly toward land in large flocks suggested they were fleeing deteriorating weather at sea. Fish jumping unusually often meant changing pressure was affecting their behavior. A storm was building. Whales and dolphins surfacing more frequently than normal might indicate pressure changes or underwater disturbances associated with approaching weather systems. While this wasn't as reliable as cloud observation, experienced sailors noticed these patterns. Even insects played a role. In coastal waters, if land-based insects appeared on the ship, it meant wind was blowing from shore, useful for understanding immediate wind direction. If mosquitoes or flies became particularly active and bitey, many sailors believed, possibly correctly, that this indicated falling pressure and incoming storms. The feel of the air had meaning too. A particular heavy feeling, difficult to describe but unmistakable once you'd experienced it, often preceded major storms. This was likely the sensation of falling barometric pressure. Humans can actually sense these changes, though we rarely pay attention to them in modern life. Vikings, whose survival depended on atmospheric conditions, developed this sensitivity to a high degree. Visibility changes were crucial. Exceptionally clear visibility, where you could see distant landmarks with unusual clarity, often meant high pressure and stable weather. But it could also mean very cold, dry air, which in certain seasons brought dangers of its own. Hazy, reduced visibility with no apparent fog might indicate humidity increasing ahead of rain. Fog itself was classified into types. Fog forming at sunrise that burned off by mid-morning was harmless. Fog rolling in from sea, thick and persistent, meant sailing blindly for possibly days and required extreme caution. Vikings would sometimes anchor rather than risk sailing in dense fog near land, despite their skill at other forms of navigation. Lightning and thunder were obvious warnings, but Vikings also knew that electrical storms at sea could be especially dangerous. Lightning could set sails on fire, strike masts, or kill crew members. Thor's hammer wasn't just mythology. It was a real and terrifying hazard that commanded respect and fear. All of this weather knowledge was synthesized constantly. A Viking navigator wasn't just looking at one sign. He was integrating dozens of observations into a holistic picture. Cirrus clouds appearing, combined with a backing wind, a halo around the moon, and birds flying low. Storm definitely coming. Better find shelter, or at least reduce sail and prepare. This predictive skill wasn't perfect. Sudden storms could still appear with minimal warning, especially in the volatile North Atlantic. But Vikings were right far more often than they were wrong, and that margin made the difference between thriving seafaring culture and one that stayed close to shore. Modern meteorology with satellites, radar, computer models, and centuries of accumulated data is obviously far more accurate. But it's worth noting that experienced sailors who learn traditional weather observation can still make remarkably good short-term forecasts without any instruments. The information is all there in the natural world. You just have to look and, more importantly, know what you're looking for. The human element, psychology, and leadership. But here's what all the tools and techniques miss. Viking navigation was also fundamentally about psychology. Long ocean crossings were terrifying. Days or weeks out of sight of land, surrounded by endless grey water, being thrown around by waves, cold, wet, exhausted, wondering if you'd ever see home again. This tested men in ways modern people can barely imagine. Crew morale mattered as much as wave reading or star positions, maybe more. A good navigator didn't just know the stars and currents. He knew people. He knew how to keep his men calm when they'd been out of sight of land for a week, and fear was starting to set in. He knew when to push the crew to keep working despite exhaustion, and when to ease off before they broke. He knew which men could be relied on in a crisis and which would panic. Part of this was routine and structure. Humans find comfort in predictability, even in unpredictable situations. Viking ships maintained watch schedules, meal times, and work rotations that gave each day shape and purpose. Men knew what was expected when they'd sleep, when they'd eat, when they'd row. This structure kept panic at bay. Storytelling was crucial. During long night watches or when storms forced the crew to hunker down beneath hide tarps, the navigator or captain would tell stories, sagas of heroes, adventures, previous voyages, legendary exploits. These weren't just entertainment. They built connection, reminded men they were part of a tradition larger than themselves, distracted from fear and discomfort. The stories also encoded wisdom, tales of how famous navigators handled specific situations, how earlier voyages overcame difficulties, how bravery was rewarded. These taught lessons while maintaining morale. When Thorstein sailed to Greenland, he faced 10 days of headwinds. He didn't turn back. He had his men row in shifts, day and night, and when they finally reached Greenland, the settlement threw a feast in their honor. Message received: endure hardship, glory follows. Humor was another psychological tool. Vikings had a particular brand of dark, understated wit that thrived even in misery. When everything was cold, wet, and awful, making a dry joke about it somehow made it bearable. Well, at least we're getting a free bath. First one this month. Laughter, even bitter laughter, released tension and reminded men they were still human, still capable of something beyond mere survival. A navigator who could joke even in bad situations was worth his weight in silver. Men would follow someone who could maintain composure and find humor in crisis. They'd lose confidence in someone who seemed afraid or overwhelmed, even if that person's technical navigation skills were better. Leadership presence mattered enormously. The navigator or captain had to project confidence, even when uncertain. This didn't mean lying or false bravado. Vikings respected honesty and despised pretension. But there's a difference between saying, "I'm not sure exactly where we are and we're lost and probably going to die." The first acknowledges reality while maintaining forward momentum. The second destroys morale and creates panic. Decision-making speed was important too. In crisis situations, sudden storms, ship damage, spotting an unexpected hazard, the navigator had to decide quickly. Not recklessly, but decisively. Men in danger need direction. They need someone to say, "Do this now," with authority and clarity. Hesitation or visible uncertainty could cause the crew to freeze or make conflicting individual decisions that led to disaster. Physical toughness was expected but had to be balanced with wisdom. A navigator who never showed weakness, who seemed immune to cold and exhaustion, earned respect, but one who pushed himself to collapse and became unable to function lost that respect. The trick was enduring slightly more than your men while still remaining capable. Managing conflict was critical on voyages lasting weeks or months. Stuck on a 50-foot ship with 20-30 other men, personality clashes were inevitable. Vikings were not particularly patient or conflict-averse as a culture. Arguments could easily escalate to violence. A good captain or navigator would intervene before conflicts boiled over, mediating disputes, separating antagonists, or, if necessary, administering rough justice to maintain order. Some conflicts were settled with formal duels once reaching land. Violence on board a ship endangered everyone. The navigator's job was to keep those conflicts from exploding during the voyage. You too have a problem? Fine, when we reach Iceland, you can settle it however you want. Until then, you're on opposite watches and you don't speak to each other. Fear management was perhaps the most crucial psychological skill. Fear is contagious. One man panicking can cause others to panic. A mass panic on a ship kills everyone. Vikings valued courage highly, but courage doesn't mean absence of fear. It means functioning despite fear. A navigator had to acknowledge danger honestly while giving men actionable tasks that kept them focused on survival rather than spiraling into terror. Yes, this storm is serious. Yes, we might not make it. But right now, you two bail water. You three secure that loose cargo before it breaks someone's legs. You keep adjusting the sail as I direct. If we all do our jobs, we'll survive this. Purpose and action combat fear far better than denial or reassurance. Religious and spiritual leadership also fell partly on the navigator or captain. Vikings were religious, believing in a pantheon of gods who directly influenced events. Before dangerous voyages, sacrifices might be made to ensure divine favor. During storms, men would pray or make vows. If we survive this, I'll sacrifice a horse to Njord. The navigator might lead these prayers, or at least not interfere with them. Some navigators cultivated a reputation for being lucky or favored by the gods. Whether they actually believed this or simply recognized its psychological value is unclear, but a crew that believed their navigator had divine favor was much more confident and functional than one that didn't. There's also the physical endurance required. Navigation wasn't just mental work. The navigator spent hours upon hours exposed to weather, watching stars, checking landmarks, taking soundings, steering or directing the helmsman, barely sleeping. On a voyage from Norway to Iceland, roughly 750 miles, that took maybe a week in good conditions. The navigator might sleep only a few hours per day in short snatches. This chronic sleep deprivation, combined with cold physical exertion and constant mental calculation, created extreme fatigue. Making sound decisions while exhausted was yet another skill that separated competent navigators from great ones. Mistakes due to fatigue killed crews. "I was too tired to check the stars carefully" wasn't an acceptable excuse when you'd led your ship onto rocks. Some navigators used assistants or apprentices to help share the workload, teaching them while also getting extra eyes on the environment. Two people watching for landmarks or hazards were better than one. This also created redundancy. If the primary navigator was injured or killed, someone else could hopefully get the ship home. The psychological burden of responsibility was immense. Every person on board trusted the navigator with their lives. Their families back home were counting on them to return. If you failed, if your mistake led to shipwreck and drowning, you didn't just die yourself. You killed your friends, your relatives, possibly your own sons or brothers. That weight, that constant awareness of responsibility required a particular type of personality. Not everyone could bear it. Successful Viking navigators combined technical skill, physical endurance, emotional intelligence, leadership ability, teaching skill, and psychological resilience. They were part scientist, part artist, part warrior, part priest, part teacher. Finding individuals with this combination of abilities was rare, which is why famous navigators were celebrated and remembered long after their deaths. Training the next generation. The transmission of navigation knowledge from one generation to the next was absolutely critical to Viking culture. Without schools, written textbooks, or formal institutions, how did young men learn to navigate across empty oceans? The answer lies in an apprenticeship system that was thorough, demanding, and began in childhood. Boys who showed promise, good spatial reasoning, excellent memory, willingness to learn, physical hardiness, would be identified early, sometimes as young as 5 or 6 years old. Often these were sons or nephews of established navigators, but not always. A boy from any family could potentially become a navigator if he had the aptitude and opportunity. Initial training happened on land. Young boys would be taught to observe constantly. Look at that mountain. What's its shape? How many peaks? How would it look from different angles? From the water? Now close your eyes and describe it to me. Memory training started immediately. They'd learn the stars by name and position, spending countless nights outside identifying constellations, watching how they moved, understanding the North Star's significance. This wasn't classroom learning, it was experiential, lying on the ground in darkness, cold, tired, forced to pay attention by cold reality rather than grades or tests. Learning to judge distances visually was crucial. How far to that island? How long would it take to row there? The boy would guess, and then they'd actually make the journey, timing it, letting the boy see how accurate or inaccurate his judgment had been. Repeat this hundreds of times and distance estimation became intuitive. First sea voyages were short and coastal. A boy might join his father or mentor on simple trips between nearby settlements, journeys of a few hours or perhaps a full day. He'd learn to handle a boat in calm conditions, understand how wind filled the sail, practice steering, row until his hands blistered and bled, and then healed into calluses. He'd learn the home waters intimately. Every rock, every shallow, every safe anchorage. The elder would constantly quiz him. "We're here. If fog rolled in right now, could you guide us back to harbour? Which direction? What landmarks would you look for?" Wrong answers weren't punished harshly, but they were corrected firmly. This knowledge would save his life someday. As the boy grew older, say 10 to 12, he'd begin longer coastal voyages, perhaps several days, stopping at different ports. Now he was learning routes, memorizing the coastline from the water perspective, understanding how different weather affected travel times and difficulty. He'd start learning wave patterns, how swells behaved near land versus open water, how current affected the ship's movement. Feel that? The ship is being pushed sideways even though we're sailing straight. That's the current. Which direction? How strong? Physical sensation became data. Teenage years brought more responsibility and longer voyages. The apprentice would be given specific tasks, maintaining the speed estimate through dead reckoning, taking soundings and reporting depth, watching for birds or other land indicators, checking the sun's position, and reporting the estimated bearing. These weren't make-work tasks. The senior navigator was cross-checking his own observations against the apprentice's reports, teaching while also getting useful information. And increasingly the apprentice would be tested. Based on everything you've observed today, where do you think we are? The answer would reveal how well the apprentice was synthesizing information. First open ocean crossings usually came in late teenage years, 16 or 17 perhaps. These were momentous occasions, not just for the apprentice, but for his family and community. If he performed well on a major voyage, say Norway to Iceland, he'd return home with increased status and respect. But these crossings were terrifying for young men. No matter how much coastal experience you had, the first time you watched the mountains of home disappear behind you and found yourself surrounded by endless ocean, it struck differently. Many boys discovered they didn't have the temperament for open ocean navigation. No shame in that. They'd apply their skills to coastal trading or fishing instead. Those who did continue would spend years on progressively more difficult voyages. Iceland was considered an intermediate challenge, far enough to be serious, but the island was large enough that you wouldn't easily miss it. Greenland was harder, smaller target, more ice hazards, less forgiving if you got lost. Vinland, North America, was expert level, attempted only by the best. Throughout this process, which might span 10 or 15 years total, the apprentice was absorbing not just technical skills, but judgment, when to take risks and when to play it safe, how to read the mood of a crew, how to make decisions under pressure, which battles were worth fighting and which should be avoided. Some apprentices never became master navigators. They'd plateau at coastal piloting or serve as assistants, but never lead major expeditions. Others would eventually surpass their teachers, making discoveries or developing new techniques that would become part of the collective knowledge base. The teaching wasn't just one way. Apprentices often made observations their elders had missed. A young man with fresh eyes might notice a pattern the older navigator had overlooked simply through habituation. Good teachers encouraged this, rewarding sharp observations regardless of the apprentice's age or status. There was also competition among apprentices. If multiple young men were training under the same navigator or within the same community, they'd naturally compete for status and recognition. Who had better memory? Who could handle storms with more composure? who would be chosen for the most prestigious voyages. This competition pushed standards higher and motivated apprentices to excel. The graduation moment, when an apprentice was finally recognized as a qualified navigator capable of leading his own voyages, wasn't formalized the way modern certifications are. It was more organic. The community consensus gradually shifted from "he's still learning" to "he knows what he's doing." Being chosen to lead a significant voyage was the real proof. From that point forward, the new navigator would begin training his own apprentices, perpetuating the cycle. The knowledge flowed generation to generation, each cohort adding their observations and experiences to the collective understanding, gradually refining techniques and building a more complete mental map of the known world. This system worked remarkably well for centuries. Its eventual decline came not because it was ineffective, but because technology changed. Magnetic compasses, paper charts, written sailing directions, and eventually GPS made the old methods obsolete. But at its peak, the Viking apprenticeship system created some of the most skilled navigators the world had ever seen. The voyages, putting it all together. Let's talk about what it actually looked like when all these techniques came together on a real voyage. Take the journey from Norway to Iceland, one of the most common major crossings Vikings made. This was roughly 750 nautical miles, typically taking about a week in good conditions, but possibly 2 weeks or more if weather was poor. Preparation began days or even weeks before departure. The ship would be thoroughly checked, hull inspected for cracks or worn areas, leaking seams recaulked with tar and animal hair, loose rivets tightened or replaced. The mast would be examined for cracks or weak points, sail inspected for tears and repaired, every rope checked, ballast stones loaded into the bottom of the hull to improve stability. Provisions for the crew would be loaded: dried fish, salted meat, hard flatbread, barrels of water and ale, dried fruit if available. For a crew of 20 men on a week-long voyage, you're looking at substantial supplies. Everyone knew that voyages could take longer than planned, so prudent captains carried extra rations. Navigation tools, such as they were, would be prepared. The sun compass, if used, a lead, line for soundings, perhaps a sunstone carefully wrapped in leather, spare rope, tools for repairs, tar for emergency caulking, extra wool cloth for patching sails. Weapons, because pirates and hostile encounters were always possible. The timing of departure was crucial. Vikings typically sailed during the summer months, roughly May through August, when days were long, weather was relatively calmer, and the risk of severe storms was lower. Attempting the North Atlantic in winter was virtually suicidal. They also timed departures based on shorter-term weather patterns. If a storm had just passed and clear weather was settling in, that was ideal. Multiple days of good weather would let them make significant progress before the next system arrived. Departure day would begin with possible sacrifices or prayers for safe passage. The ship would be pushed from shore or rowed out of the harbor. Once in open water with enough room to maneuver, the sail would be raised, the distinctive square. Viking sail, billowing in the wind, would fill, and the ship would begin its voyage west. For the first day, the Norwegian coast would still be visible astern, growing gradually smaller. The crew would settle into watch rotations, some men resting, others on lookout, the helmsman steering under the navigator's direction, a few men bailing water that inevitably seeped through the hull. The navigator would take a sun compass reading if conditions allowed, establishing their heading. He'd estimate their speed by watching objects floating past the hull, or by the feel of the wind and water. 5 knots was good progress. In ideal wind conditions, a Viking nar might manage 7 or 8 knots, covering perhaps 150-180 miles in a day. By the second day, Norway's mountains would have disappeared below the horizon. Now they were truly at sea, surrounded by water in all directions. This is when the psychological challenge began for less experienced crew members. The absolute emptiness of the ocean, the constant motion, the loss of any reference points, it could be deeply unsettling. The navigator would maintain dead reckoning constantly. We've been sailing west-northwest for roughly 18 hours at approximately 6 knots. That puts us maybe 100 miles from Norway. Iceland is still 650 miles ahead. At this pace, 4 more days if conditions hold. Night would bring a shift in navigation methods. As soon as stars appeared, the navigator would locate Polaris and check their latitude. If they drifted north or south during the day due to current or imprecise steering, course corrections would be made. The Big Dipper's position would give a rough time estimate. Watches would rotate through the night. Men would sleep in shifts, huddled under wool cloaks or hide tarps, never truly dry, never truly warm. The ship would continue sailing, the helmsman making constant tiny adjustments to keep the sail filled and the heading steady. By day 3 or 4, they'd be in the middle of the Iceland-Norway passage. This was the most psychologically challenging phase, furthest from any land, completely committed. No turning back at this point. You had as far to go backward as forward. The navigator would watch obsessively for any indicators of their position, changes in watercolor or temperature. Seabirds, though in mid-ocean, these would be rare. Floating debris, the angle of the sun at noon, anything that confirmed they were still on course or revealed drift. Weather systems would pass through, a day of rain and wind forcing the crew to reduce sail and bail constantly, then clearing, allowing them to dry out somewhat and make better progress. The navigator would use each clear period to verify position and heading, knowing the next overcast might last days. Around day 5 or 6, if all went well, the first signs of Iceland would appear. Seabirds in increasing numbers, puffins, gulls, Arctic terns, changes in wave patterns as swells interacted with Iceland's underwater shelves, watercolor shifting from deep blue to more greenish, possibly floating seaweed. The navigator might release a raven if he had one, watching which direction it flew, or simply sail on, confidence building, as indicators accumulated. We're close, possibly 12 hours away, maintain current heading. And then, finally, a shout from the lookout. Land! A thin, dark line on the horizon ahead, barely distinguishable from clouds at first, but growing clearer. Mountains, Iceland's southern coast rising from the sea, the relief among the crew would be palpable, but the voyage wasn't over. Now came the delicate work of coastal navigation, identifying which part of Iceland they'd reached, adjusting course toward their specific destination, watching for hazards. Soundings would be taken frequently, checking depth and sediment. They might arrive slightly east or west of their intended harbor. No problem. The navigator would recognize landmarks, adjust accordingly, and guide the ship along the coast to their destination. By nightfall or the next morning, they'd be pulling into harbor, crew exhausted but triumphant. Total distance covered, perhaps 800-900 miles, accounting for not sailing in a perfectly straight line. Time elapsed, 6 to 8 days typically, though it could be as little as 4, in exceptional conditions, or as long as 2 or 3 weeks if weather was poor. And this was considered a routine voyage. Vikings did this dozens or hundreds of times, establishing regular trade routes, ferrying settlers and supplies, maintaining communication between Norway and Iceland. It became so common that we take it for granted. But think about it. Crossing 750 miles of open ocean in a wooden boat powered by wool, using no instruments except maybe a wooden disc and a rope, finding a landmass smaller than many modern states, arriving safely more often than not. Remarkable. The Greenland voyage was even more challenging. From Iceland to the southern tip of Greenland was another 450 miles or so, but through much more dangerous waters. Pack ice from the Arctic drifted south, creating fields of floating ice that could crush a wooden hull. Icebergs carved from Greenland's massive glaciers posed another hazard, some the size of small islands, others barely visible above water, but with massive underwater rams waiting to hole a ship. Weather in this region was more volatile. Fog was frequent and could persist for days, making navigation nearly impossible. Storms appeared suddenly, driven by the interaction between Arctic air and warmer Atlantic currents. And Greenland itself was mountainous and difficult to approach, with treacherous currents and few good harbors on the eastern coast. Vikings sailing to Greenland would use latitude sailing, maintaining a specific parallel that would lead them to known settlements on the southwest coast. They'd watch obsessively for ice, which appeared in predictable zones but could drift unpredictably due to currents and wind. Some years the ice was worse than others, occasionally making the approach to Greenland completely impassable. The discovery of Greenland itself, around 982 CE by Eric the Red, was partly accidental. He'd been sailing from Iceland, blown off course by storms and stumbled onto Greenland's coast. But subsequent voyages were deliberate, using the knowledge Eric brought back to establish a route. The Vinland voyages, reaching North America around 1000 CE, represented the absolute edge of Viking exploration capabilities. From Greenland to Newfoundland was perhaps 1,500 miles through waters no European had ever sailed. These voyages were rare, attempted only by the most skilled navigators, and even they had a high failure rate. Leif Erikson's discovery of Vinland, like his father's discovery of Greenland, involved some luck. He was trying to reach Greenland from Norway and was blown off course to the west. But he managed to navigate back, report his discovery, and subsequent voyages deliberately sought out this new land. These North American expeditions failed to establish permanent settlements, not because of navigation difficulties, but due to conflicts with indigenous peoples and the sheer distance making regular supply impossible. But the fact that Vikings reached North America at all using Bronze Age navigation techniques remains one of history's most impressive achievements. When navigation failed, disasters and lessons. For all their skill, Viking navigators weren't infallible. Ships were lost regularly, sometimes with all hands. These disasters were traumatic for communities, devastating to families, and yet also sources of learning. Understanding how and why ships failed improved future navigation. Some disasters were due to weather overwhelming even experienced navigators. A sudden storm catching a ship far from any harbor, winds too strong for the crew to manage, waves smashing the vessel to pieces. Men could only bail, pray, and hope. Some survived by clinging to wreckage until washing ashore. Most drowned. Navigation errors killed too, mistaking one headland for another in fog, sailing confidently toward what you thought was a safe harbor, only to run aground on rocks. Underestimating drift and missing Iceland entirely, sailing past into empty ocean until water and food ran out. Errors in latitude estimation putting you hundreds of miles north or south of intended course. The sagas record some of these failures. Ships that left Norway for Iceland and were never seen again. Vessels that disappeared without a trace, their fate unknown to this day. Archaeologists occasionally find shipwrecks that tell these stories in physical form. Shattered timbers on a reef, human remains amid cargo, evidence of the final moments. Ice was a particular killer in Greenland waters. A ship could become trapped in pack ice, unable to move, slowly being crushed as ice floes pressed together, or a ship might collide with an iceberg, in fog tearing open the hull and sinking in minutes. Some crews abandoned sinking ships and tried to survive on ice floes, but without shelter or supplies, survival time was measured in hours in Arctic conditions. Provisioning failures could be fatal. If a voyage took longer than expected due to headwinds or getting lost, food and especially water would run out. Men weakened by thirst and hunger became unable to work, the ship became harder to control, and a vicious cycle began. Some ships limped into harbour with half the crew dead or dying from dehydration. Mutiny occasionally occurred when crews lost confidence in their navigator. If men believed they were lost, fear could overcome discipline. Arguments, fights, sometimes murder of the navigator or captain. These situations rarely ended well. Even if the mutineers survived, they'd be outlawed when returning home, their names dishonoured. Disease could devastate crews on long voyages. Though Vikings didn't understand germ theory, they knew that sickness could spread through a ship. Dysentery from contaminated food or water, infections from injuries, pneumonia from constant cold and wet. A sick crew was nearly as helpless as a lost one. Ship structural failures claimed vessels too. A mast cracking in high winds, leaving the ship unable to sail and at the mercy of currents. Hull planks working loose in severe seas, leaking faster than the crew could bail. Rudder damage making steering impossible. Vikings were skilled shipwrights and carried tools for emergency repairs, but some damage couldn't be fixed at sea. Pirates and raiders were risks on certain routes, though less common on the open ocean crossings to Iceland or Greenland. Still, a ship damaged in combat, even if it drove off attackers, might be so compromised it couldn't complete its voyage. Each disaster, when survivors made it back or when wreckage was found, taught lessons. The navigation knowledge base was refined by failure as much as success.
Don't approach that headland from the north in southerly wind. There's a current that sets you onto the rocks. If you see ice in June, you've sailed too far north. Adjust course south immediately. That underwater ridge has less clearance than we thought. Take soundings more frequently approaching from the east. These lessons were incorporated into the oral tradition, passed to new navigators, slowly improving safety. But the ocean always held the final word. No matter how skilled, how experienced, how careful, sometimes the sea simply won. Vikings accepted this with fatalistic pragmatism. The ocean gave them their livelihood, connected their communities, opened pathways to new lands. But it demanded payment in lives. This was simply the nature of their world. The cultural context. Why navigation mattered. It's important to understand that navigation wasn't just a technical skill for Vikings. It was central to their entire culture and worldview. The sea wasn't an obstacle or
barrier. It was a highway, the primary means of communication, trade, warfare, and expansion. Being a skilled navigator wasn't just prestigious, it was essential to Viking identity. In Norse mythology, the sea and sailing featured prominently. Njord was the god of the sea, winds, and fishing. Ran was the goddess of the sea, known for dragging sailors to their deaths with her nets. A metaphor for drowning that Vikings knew all too well. Even the gods travelled by ship, and the mythological world was often described in terms of journeys across water. The ship itself was sacred in Viking culture. The finest ships were given names and treated almost like living beings. When important people died, they were sometimes buried in ships, sent to the afterlife as they had lived, sailing. The famous Oseberg and Gokstad ship burials discovered by archaeologists reflect this deep connection between Vikings and their vessels. Social status was tied to navigation skill. A man who'd successfully navigated to distant lands commanded respect. His voice carried weight in community discussions. His advice was sought. His sons might marry into more prominent families based partly on the father's reputation as a navigator. Conversely, a failed navigator brought shame not just on himself, but on his family. The families of men who died due to navigation errors suffered socially and economically. This created intense pressure to succeed and powerful motivation to learn the craft thoroughly. Navigation knowledge was also political power. A chieftain or jarl who controlled the most skilled navigators controlled trade routes, could launch raids effectively, could communicate with distant allies, could relocate his people to better lands if needed. Navigation expertise was a strategic resource, hoarded and protected. This is why navigators were sometimes targeted in battles. Killing the enemy navigator could strand their fleet or send them hopelessly off course. Capturing an enemy navigator and forcing them to reveal routes and techniques was valuable. Some navigators carried this knowledge to their graves rather than reveal it under torture. The emphasis on exploration and expansion in Viking culture was only possible because of navigation skill. Without confident ocean-crossing ability, Vikings would have remained in Scandinavia, just another medieval culture. Navigation unlocked Iceland, Greenland, and North America, created trade networks extending to Constantinople and Baghdad, enabled the raids that terrified Europe. Even Viking concepts of honor and courage were tied to navigation. Facing the ocean's dangers without flinching, maintaining composure during storms, persevering when lost. These demonstrated the core Viking values of bravery, self-reliance, and endurance. A man who showed fear at sea or who begged to turn back during a difficult voyage would be mocked and marginalized. The economic implications were huge. Fish were a staple food, and fishing required navigation even if just coastal. Trade goods, furs, walrus ivory, iron, timber, amber moved by ship. Raiding, for all its violence, brought back wealth that enriched communities. All of this depended on getting ships safely from point A to point B. Settlement of new lands was perhaps the most important long-term consequence. Iceland was uninhabited when Vikings arrived and settled it in the late 800s. Today, Iceland has a population descended partly from those original settlers, speaking a language remarkably similar to Old Norse. That entire nation exists because Viking navigators could cross the North Atlantic reliably enough to establish permanent communities. Greenland's Norse settlements lasted about 500 years before disappearing, probably due to climate change and economic isolation, but for half a millennium, European-descended people lived in the Arctic, an extraordinary testament to both navigation skill and human adaptability. The Vinland settlements in North America didn't last, but they proved that pre-Columbian contact between Europe and the Americas had occurred. This rewrites the historical narrative of discovery and reminds us that the barriers between continents weren't as absolute as later European historians believed. The decline of Viking navigation. The traditional Viking navigation methods began to decline in the 12th and 13th centuries, not because they stopped working, but because new technologies and political changes made them less necessary. The magnetic compass, invented in China and transmitted westward through trade networks, reached Europe around the 12th century. Early compasses were crude, a magnetized needle floating in water or balanced on a pivot, but they provided directional information without needing to see the sun or stars. This was revolutionary. Vikings initially resisted compasses, viewing them with suspicion. The oral tradition and memory-based navigation had worked for centuries. Why trust a mysterious device? But gradually, the practical advantages became undeniable. Compasses worked in any weather, day or night, required no expertise to read. Navigation became more accessible to less skilled sailors. Written sailing directions called portolans, or rutters, began appearing. These described routes with specific instructions, distances, depths, and hazards. What had lived in navigators' memories was now codified on parchment. This democratized navigation knowledge. Anyone literate could potentially follow a route without years of apprenticeship. Paper charts, developed in the Mediterranean and spreading northward, showed coastlines, harbors, and hazards visually. While early charts were inaccurate by modern standards, they were better than no charts at all. The mental maps that Viking navigators had carried became external, shareable, improvable through collective effort. Political changes mattered too. The Viking Age is generally considered to have ended around 1066 CE with the Battle of Stamford Bridge and the Norman conquest of England. The great age of Viking expansion and raiding was over. Scandinavia was Christianizing and becoming more settled, less focused on overseas adventure. Trade networks shifted. The Hanseatic League, a confederation of merchant guilds and market towns in northern Europe, came to dominate Baltic and North Sea trade. These merchants used larger ships, written contracts, standardized routes, a more organized, less individualistic approach than Viking seafaring. Iceland, Greenland, and the Norse settlements became more integrated into European trade networks rather than being Viking-exclusive domains. Ships from other nations began making these crossings, bringing their own navigation methods and technologies. The Greenland settlement's decline and eventual disappearance in the 15th century removed one of the main reasons for maintaining the most advanced navigation techniques. Without Greenland as a destination, the difficult Arctic crossing skills became less necessary. They were still remembered in sagas and stories, but no longer practiced regularly. By the Renaissance, European navigation had evolved significantly. The astrolabe and later the sextant allowed precise latitude measurements. Improved charts showed the world with increasing accuracy. The development of longitude calculation in the 18th century finally solved the east-west position problem that had bedeviled navigators for millennia. The old Viking methods, reading waves using sunstones, latitude, sailing by Polaris, mental mapping, were forgotten or dismissed as primitive superstition. European navigators of the 1500s-1700s viewed themselves as far more advanced than their medieval predecessors. In some ways they were. But they'd also lost something, that intimate, embodied relationship with the sea that Viking navigators had possessed. Modern rediscovery and recognition. For centuries, Viking navigation achievements were downplayed or misunderstood. Historians assumed that Vikings must have stayed within sight of land or island hopped, unable to make true open ocean crossings. The saga accounts of voyages to Iceland, Greenland, and Vinland were sometimes dismissed as exaggerations or myths. It was this skepticism persisted until the late 19th and early 20th centuries, when serious archaeological work began uncovering evidence. The excavation of Viking ships like the Oseberg and Gokstad vessels in Norway proved that Vikings had ocean-worthy ships. The construction quality, design sophistication, and seaworthiness of these ships demanded that historians reconsider. The discovery of Lance O Meadows in Newfoundland, Canada in the 1960s was a watershed moment. Here was physical proof, Norse structures, artifacts, a settlement clearly built by Vikings around 1000 CE. This confirmed the saga accounts of Vinland. Vikings had indeed reached North America half a millennium before Columbus. Modern experimental archaeology has further validated Viking capabilities. The reconstruction of Viking ships and actual ocean crossings using these replicas has proven that the voyages were not only possible, but entirely practical. In 1893, the Viking ship replica Viking sailed from Norway to Chicago for the World's Fair, crossing the Atlantic successfully and demonstrating the ship's oceanworthiness. More recent experimental voyages have attempted to use only traditional navigation methods: no compass, no GPS, no charts. These experiments have shown that experienced sailors, after training in wave reading, star navigation, and other Viking techniques, can successfully navigate across open ocean. It's challenging but absolutely doable. Scientific research on sunstones, as mentioned earlier, has provided a plausible mechanism for navigating under overcast conditions. Studies published in respected journals have demonstrated that calcite and other crystals can indeed detect polarized light patterns and locate the sun through clouds. Whether Vikings actually used this technique is still debated, but it's no longer dismissed as impossible. The field of cognitive archaeology has explored how oral cultures transmit complex knowledge systems. Research into memory techniques, spatial cognition, and embodied knowledge has made Viking navigation less mysterious. We now understand better how humans can develop extraordinary spatial memory and environmental awareness when their survival depends on it. Modern navigation training programs, particularly for sailing, sometimes incorporate traditional techniques as backup methods. If all electronics fail, GPS goes down, compass is lost, charts are destroyed, knowing how to navigate by sun and stars, how to read water and weather, how to take soundings, these skills become relevant again. There's also growing recognition that different cultures developed sophisticated navigation independently. Polynesian wayfinding, Arab Indian Ocean navigation, Chinese coastal piloting, all reached high levels of skill without modern instruments. Viking navigation is now understood as part of this broader human capacity for spatial orientation and travel across seemingly impossible distances. The environmental knowledge that Vikings accumulated is also being re-evaluated. Their understanding of ocean currents, seasonal weather patterns, ice movement, and marine ecology was extensive and largely accurate. Modern oceanography and climate science have confirmed many observations that Vikings recorded in sagas or passed down orally. These weren't primitive superstitions, they were empirical observations refined over generations. There's even some poignancy in recognizing what's been lost. Modern sailors, for all their technology, often lack the deep environmental awareness that Vikings possessed. We navigate by screens and satellites, isolated from direct experience of the elements. When technology fails, as it occasionally does, many modern mariners are helpless in situations Vikings would have handled routinely. Some modern sailors and researchers are working to preserve and revive traditional navigation methods, not as museum pieces, but as living skills. Schools teach celestial navigation. Sailing programs emphasize traditional techniques. The goal isn't to abandon modern technology, but to maintain the knowledge as backup and to preserve cultural heritage. Why it matters. Today, you might wonder why any of this matters in the age of GPS and autopilot. Why should we care about how Vikings navigated when we have satellites tracking our every move? There are several reasons. First, there's the historical significance. Understanding how Vikings navigated helps us understand how they accomplished what they did. The settlements, the trade networks, the cultural exchanges. It contextualizes sagas and archaeological finds, turning Viking Age history from vague mythology into concrete, understandable human achievement. Second, it demonstrates human capability and adaptability. Vikings weren't superhuman. They were people with the same basic cognitive abilities as us, working with limited technology but unlimited ingenuity. They proved that humans can accomplish extraordinary things through patient observation, accumulated knowledge, and cultural transmission of expertise. Third, it offers perspective on our relationship with technology. We're incredibly dependent on GPS, charts, and electronic systems, but these can fail. Satellites malfunction, electronics get wet, batteries die. Knowing that people once navigated successfully without any of these tools is both humbling and reassuring. The skills are still theoretically accessible to us if needed. Fourth, there's the environmental knowledge aspect. Vikings developed their navigation methods through intimate, sustained attention to the natural world. They read clouds, waves, birds, stars, ice, water temperature, and 1,000 other environmental signals. This level of attunement to nature is rare in modern life. Studying how Vikings did it might inspire us to pay closer attention to our environment. Fifth, it's a reminder about knowledge preservation. Viking navigation knowledge survived for centuries through oral transmission, but much was eventually lost when that transmission chain broke. How much valuable knowledge is at risk today because it's stored in fragile formats or known only to aging experts? The Viking example warns us about the consequences of failing to pass knowledge to the next generation. Sixth, there are practical applications. Traditional navigation techniques are still taught to military pilots and sailors as backup skills. If you're shot down behind enemy lines or shipwrecked on a deserted coast, knowing how to navigate by stars and sun could save your life. These aren't just historical curiosities, they're survival skills. Seventh, understanding Viking navigation contributes to cognitive science and educational theory. How did human brains develop such sophisticated spatial memory and environmental reasoning? What teaching methods most effectively transmit complex knowledge systems? The Viking apprenticeship model offers insights that might inform modern education. Eighth, there's the inspiration factor. The story of Vikings crossing vast oceans in wooden boats using stars and wave patterns and sheer determination is inherently inspiring. It reminds us that humans are capable of far more than we often give ourselves credit for. When facing our own challenges, whether personal, professional, or societal, the Viking example encourages us to trust observation, accumulate knowledge, learn from failures, and persist despite fear. Finally, there's simply the intellectual satisfaction of understanding how something worked. Vikings navigated, that's a fact. But how exactly did they do it? What combination of techniques, technologies, knowledge, and skills made it possible? Answering these questions is inherently worthwhile, part of humanity's ongoing effort to understand our own history and capabilities. Conclusion: the legacy of Viking navigators. The Viking navigation system represents something profound about human capability. These weren't people with advanced technology. They didn't have computers or satellites or even paper charts. They had observation, memory, courage, and a willingness to learn from both success and disaster. They proved that you don't need technology to explore. You need attention, patience, and willingness to learn from the world around you. You need teachers willing to share knowledge and students willing to endure years of difficult training. You need a culture that values exploration and is willing to accept that some explorers won't come home. Every time a Viking ship made landfall in Iceland, Greenland, or Newfoundland, it was a victory not of tools, but of mind, of human beings paying such close attention to the world, the waves, stars, birds, ice, wind, water, that they could read it like a book written in 1,000 subtle languages. Modern sailors, even with GPS, sometimes get lost. Vikings, with none of that, sailed to America 500 years before Columbus, not by accident, not by luck, by design, skill, and a deep, hard-won relationship with the sea that took generations to develop and could be lost in a single generation if not carefully maintained. So the next time you check Google Maps or tap a navigation app, take a moment to remember your ancestors crossed oceans using sunlight, star positions, bird behavior, wave patterns, and courage. They didn't conquer the sea. They learned to listen to it, to read it, to work with it rather than against it. And in that listening, in that patient attention to the natural world, they found their way across impossible distances. They discovered new lands. They established communities that still exist today. They proved that the ocean, vast and terrifying as it was, could be understood, not tamed, never tamed. The ocean doesn't allow that, but understood enough to navigate, respected enough to survive, and that understanding, that respect, that hard-won knowledge passed from navigator to apprentice across generations. That was the true magic of Viking seafaring. No supernatural powers, no mythical crystals that pointed the way, just humans, wood, wool, and an unshakable determination to see what lay beyond the horizon and then to find their way home again to tell the story. That's the legacy of Viking navigation, not just the routes they opened or the lands they settled, but the proof that human beings, armed with nothing but curiosity and careful observation, can navigate any ocean, cross any distance, find any destination. All you need to do is pay attention to the world, listen to what it's telling you, learn from those who came before, trust your training, and when you can't see the shore anymore and you're surrounded by endless water, and you're not entirely sure where you are, keep sailing anyway. The Vikings did, and they found their way. So can we.